Well, good morning, everybody. I want to start off in Texas this morning by looking at some satellite data from yesterday and just kind of make a point about what's happening as we have this seasonal transition into summertime. And the point is simply this. Summer is basically defined meteorologically as the shift in the jet stream farther and farther to the north and the weakening of the overall flow. And the reason that happens is because the atmosphere is basically warming more consistently north to south. We're losing the poleward temperature gradient simply because the northern hemisphere is pointed toward the sun and we have longer days and basically more direct sunlight. Now, all that means is simply this. We lose the big fronts and the big low pressure systems that we have during the spring and during winter that come back in the fall, which means we have to watch much more subtle boundaries on which to lift air. In other words, we lose the frequency of big fronts and we start to watch for much weaker features that can still trigger storms. Okay, so I bring all of that up because I want to tell you what we have to watch all summer. We covered yesterday the severe weather that ripped through this part of Texas and eventually got all the way down to the Gulf Coast. This is what it looked like on satellite. But what was interesting about this is all outflow from those storms. So the storms generated their own front, and it's been pushing across Texas. Well, at least it did yesterday. And when I got all the way over to western Texas, this is where new storms began to ignite later on in the afternoon. And you can see them all blowing up right here. So these storms would not have existed had these storms not been here. And this is what makes forecasting challenging. Because if you imagine you were forecasting this with a computer model, and the model didn't simulate those storms correctly, didn't produce that outflow, you never would have seen storms in the forecast model showing up. But then they blow up like this. This is how sophisticated our models are now, that they're able to capture this, because we saw these happening yesterday in the model before they did. Now, what's just amazing about them is the sun sets here. Is this was some exceptionally deep convection. These are very large anvils. We can see overshooting tops, and we can continue to monitor the outflow of these storms even as they passed over the Cap Rock and got into parts of New Mexico. Now, I'm just focusing on Texas because this is a good example of what will likely be happening across the country, not just oriented north-south, but any which direction as we progress towards this typical summer weather pattern. So that's it. We're watching those huge storms in this area, and on radar, it was absolutely spectacular. Watch the animation here. Can you see the outflow boundary and the storms that initiated on it? I could watch this stuff. I know I say that a lot, but I find this fascinating. Just to watch one set of storms, nasty, that rolled through parts of the Gulf Coast here, and their outflow, right there, see it? Generating these large storm cells that ripped through parts of western Texas. Now, of course, I have a lot of friends and colleagues in this area, and they were desperately needing the rain from these storms. But unfortunately, these storms being so deep in the atmosphere with such powerful updrafts did produce quite a bit of hail. If we just take a look at the last 24 hours of hail as measured by radar, we can kind of zoom in here on the southern plains and see just the sheer amount of hail that came out of some of these storms. A lot of 2 to 3 inch hailstone sizes were reported in a couple of locations, even larger than that. In fact, we had one just outside of Houston that reported a 4-inch diameter hailstone. Now, we had other storms in this as well. We had something that upper level wave coming through the northwest. We had the backside of this system that rolled through parts of the Midwest here. I don't know if I said Midwest or Northwest. This is the Northwest, Midwest, and then the storms here. And later on today, it's going to be a discussion about the storms that blow up in this particular area. But I wanted to show you the storm reports. We added another 227. By the way, the official number right now for preliminary reports back on the 26th is over 1,300. So that number continues to climb as we get more data in. But just taking a look here at a lot of these hail reports that came through this area, plus the strong winds that were near Dallas-Fort Worth that made it all the way to the Gulf Coast. Total rainfall just in the last 24 hours. Again, now you can see all three pieces. The shortwave in the upper parts of the northwest here coming through Idaho into Montana. The one large low that's leaving, believe it or not, this is all still rain from the weekend system. Storms coming around the back side of this as it slowly spins its way off, in the Canadian Maritimes. And then the convection that blew up yesterday and the weak little wave that snuck out of Mexico into Texas that helped the storms that formed through here produce outflow that ran into that to give the lift. That's what it is. It's about getting air to rise. All right, thinking through this all, where are we today? Well, wherever we just had all that moisture or the change in wind direction, we've got cooler temperatures. So in Texas, on the back side of this system that's moving through the East Coast, and the new wave that just came through parts of the Pacific Northwest, cooling things off here. And that's going to take me to the upper levels of the atmosphere to show you what we've been really discussing now this week that we've hinted at last week, and that is where this pattern might be going. Now today, it'll be this short wave right here, moving into this large ridge that's out ahead of it, that's going to initiate storms. They're going to come off of kind of the high plains, western plains, off the Rocky Mountains and move east. They're not going to be fast moving east, and it's largely because of this ridge out ahead of it just slowing their progress. But to be honest, while this moves across the country, my attention is going to be paid to this high pressure cell and this high pressure cell. And we've been watching these guys for a while. We've talked about the flow coming around these two ridges while there's a deeper trough of low pressure sitting somewhere in the Bering Sea or over Alaska. It shifts around day to day. But ultimately, in determining where this pattern could go as we make this summer transition, will be determined this year by the Pacific and not the Atlantic. Last year, it was all about the Atlantic. It was all about the Bermuda High. So this is what I'm talking about. I put this out in my report yesterday. If you want access to that report, it's a more in-depth technical report, but it goes out every Monday around midday. You can sign up for it on agweather.com. It's just on the top right corner of my website. But I put this together just trying to understand where the May pattern has been. And we can look at it in a couple different ways. Look over here on the right first. This is what's happened in terms of the jet stream level winds. There's our two ridges we just talked about. And the flow's been very fast north of them. And one of the reasons for that is there's great contrast in temperature here with warm south, cold north. Now that's what you need to get the jet stream to crank. That's why winter jet stream patterns are so fast. That warm south, cold north, that polar temperature gradient is strong. Now, right now, it's been shoved pretty far to the north right here. So I make some statements here. If the pattern's going to change, it has to be along that boundary. Because even though the Atlantic has got its own problems, like the Bermuda High is gone, it's split into two pieces, highly amplified flow across the North Atlantic, leading to this pattern across, this part of Europe into Russia and Asia. We'll talk about that at the end of this video. If we're going to break anything down, it's got to happen with these two ridges. And we're starting to see some evidence of a few things that could push against it. So get yourself oriented here. You're now over by Japan and China. And there's a typhoon, the remnants of one here, and there's a deeper low that's to the north of Japan, and another low here. And there's some evidence in the forecast models that's now been consistent for 5 days that these features are going to work their way into the flow such that we could start to displace these large ridges. So where are the ridges? There's one here, and there's one there. Those are the two ridges we just saw on the other kind of shifted projection of this map. And the question is to whether or not these two features might have what it takes to move this around and give us something different for the month of June. All right, so given that, let's go have a look at it. Now, it may not look like much, but this is at 500 millibars, the first tropical system. Here's the deeper low north of Japan. And then here's Ridge 1 and Ridge 2. And then you've seen all the systems rolling over the top of them. Now, it's subtle right now when you look out there later on today, but what we're watching for is simply this. Playing through Friday into Saturday and Sunday, those troughs kind of coalesce into this. The lead one makes it here. Now, there's no difference in this yet because we've seen a lot of that, which means we're going to take a look at the precipitation pattern for the next 5 days, and you'll see a lot of storms where they've been. But what we're curious about is the model's consistent change around June 5th. There it is, June 5th, 6th, and 7th, driving this trough right through the middle of those large ridges we've seen in place for so long. Now, I could sit here and look at this and try to come up with a thousand different reasons as to why it's happening. Is it the MJO? Is it changes in the North Atlantic? Is it something going on in the Arctic? Is it the tropical system pushing into this? I'm just going to say I don't know fully what to attribute all of the change to. But I will say that the model's been pretty consistent with it because it's not just the artificial intelligence. Take a look. Here's the GFS ensemble. Same scenario. See this? And if you come out here, the new European ensemble that may have just started. Yeah, the new 6E came in. Let's go out and look at that far out, about 10 days out. It's doing the same thing. So this is a shift. This is going back to what we call that positive PNA pattern, a big ridge across the west. And the idea, if you get this pattern, is heat will follow this. The flow will come over the top, and it will come out of the northwest into the plains out of the prairie, Canadian prairie, into the Midwest. We'll likely see wetter conditions to the south and along the eastern side of this trough, but for a while, northwest flow, even into early June, is drier. At some point, though, what we'll end up getting coming around ridges just like this, should this last deeper into June, are little subtle shortwaves that just kind of sneak through. They're not much. They're little features, and they're enough to start to trigger the development of thunderstorm clusters that then blow up and cascade over the top of the ridge. But we've got to get into the summer heating, like real summer heating, to make that happen. And what I showed you right now is we've got cooler air in place here, and this flow is going to be driving that cooler air in for a while into the beginning of June. So in summer, if you showed me this pattern, I'd say this would be a very stormy corridor. But in late spring, no, it's drier. So with all of that as kind of the flavor as to where this is going, let's take a look at what it means. Over the next 7 days, most of the next 7 days, we aren't deviating from where we've been. We have to wait for that trough feature to kind of take over and split that ridge feature that's been stuck in the North Pacific. But it appears that once you go from day 0 to 7 to day 8 through 14, we start to get that ridge building in, and we'll show you the heat in a few minutes. The flow comes over the top. The unsettled weather stays here and rolls east. Now, I know it's shown drier in this area, but I think it's I need you to see that drier does not mean dry. And even though you see these drier colors here, this won't be dry either. There will still be flow and daily convection and things like that happening in this pattern. So now that you know where I'm taking all of this, let's get into the latest all-hazards weather map. This was at 6 a.m. this morning, about the time I was recording. And we're not dealing with too much across the country. A few areas of some stronger winds, some frost risk here, and still the excessive heat possible down in parts of Texas. If we take you to where the storms are likely to be today, it's going to be coming off of that wave. Remember, the flow's got this sharp short wave here and this large ridge that's building up ahead of it. So we're going to watch a narrow corridor in through here, also storms down farther to the south and into Texas. And the storms that are going to be here over parts of the Ohio Valley, but moving into the mid-Atlantic, getting up into parts of the Northeast, are going to be associated with a shortwave finally exiting the East Coast here. Tomorrow, we're going to pay attention from eastern Colorado all the way down to this part of Texas. And then we're going to watch on the 31st, much of eastern Texas, which, as we've been talking about, has seen a tremendous amount of rain as of late. Let's go right into the high-res NAM. Let's pick this up right about now. So let's start at 8 o'clock. And we'll just play through the middle and end of today. So you're going to watch the storms erupt here in the models. Isolated storms are going to be through this part of the country. And then we're going to watch storms exit over here by this evening, getting into early tomorrow morning. So what we'll need to watch carefully is in the overnight hours, how do these storms survive through the overnight hours? And where do they end up, possibly dumping some very heavy rain on already saturated ground in parts of the eastern Dakotas, but sliding a bit farther to the south. What I'll be watching is the evolution of these storms, should they form properly in eastern Colorado, to move into some extremely dry area in parts of central Kansas. We've been highlighting that for months now, and I would like to see if those storms do in fact survive this. I'm going to go take a closer look here. Let's go to the south central kind of view of this and just see what the models are suggesting for that part of Kansas. So here come the storms. This is late tonight out of Colorado. We're just going to keep an eye to see if they can hold it together into the early morning hours to start to deliver some moisture there. So that'll be something to watch on radar tonight. Then as we get into tomorrow, remember that the risk is going to be on Thursday night much farther to the south. And again, see the storms just lining up right in through this part of Texas, possibly delivering some really heavy rainfall and hitting that region pretty hard. We're going to see how these clusters of storms progress east. Now, the models have taken on kind of a life of their own here, producing this quasi-linear event that's got a big bookend vortex. This is the NAM. We'll just take it for what it is, but just understand that that's where the risk of storms is going to be when we get into the day on Thursday. Okay, beyond that, next 7 days, I'm kind of seeing a couple of different things. We know we have a few more troughs coming into the northwest, hence the wetter conditions here and here, mostly lined up with the mountains. But there's a couple of areas, one here and one in through here, that are showing up wetter in the artificial intelligence. It's a bit different from what the NBM is suggesting. It's kind of there, but the NBM has these couple of different areas as well, just a little bit different progression and total amount. But you can also see the moisture continue to line up here in the northwest on the mountain ranges. This is the WPC forecast, very similar to the NBM. And here's the newest European model forecast for the next 7 days. From there, the GFS. And the GFS is, I'll show you this in a few moments, is very much trying to blow up some incredibly big storms and heavy rain in this part of Kansas. And eastern Kansas versus central and western have had entirely different precipitation regimes this spring. Now, I know I'm focusing primarily on where the wet weather is going to be in this pattern. We're a bit drier in the southeast, drier in the northeast, drier in this part of Ontario into Quebec. There's other places to be discussing here, but I think if we just watch the models play this forward, we'll see those a bit better. So here's this morning on Wednesday, playing through Thursday morning and afternoon, getting into Friday. So we've already kind of seen that in the NAM. If we play this forward, that boundary continues to slide farther to the east as we get into the day on Saturday. Remember, this is the same boundary that today is producing the storms here. It's slow because of the ridge that's out ahead of it. And as we watch from Saturday into Sunday, here's our next wave pushing into the northwest. So remember, we still have another week of the pattern that we've been in. And we're going to see a lot of scattered storms out ahead of this. This is Monday. And then what we'll be watching for here is to know if this is kind of our last low out of this pattern we've been in for better than 50 days. Because after this, the 6th into the 7th, that low begins to curl up. Higher pressure builds in here. The flow is now coming over the top, and there's our leftover trough still sitting here. But this is when the larger ridge starts to push its way into the western United States. So you notice that most of that forecast has a similar look to it to what you've seen. So that's no surprise that over most of the next 10 days, we keep this stormier pattern in place with the highest probability of having an inch of rain in this corridor. But if we look out there beyond that, this is where we end up by day 10. And there's a trough here now. We've had ridging here for a while. The ridging now splits. Part of it moves here, dives into a broader trough. There's our ridge axis running right along the Continental Divide. There's kind of split flow in the west with a trough to the south, a ridge to the north. And that is one of the reasons why all three of our forecasting models that look out into week 2, like the CPC, the European, and the GFS, are finally breaking away from this really active look. Now, what is interesting is the fact that the European trended back toward normal precip here. The GFS is a bit wetter here, and the CPC is showing this too. We can largely thank the fact that there's a weak trough feature to the south of the ridge. So there's like, sometimes in this pattern we get little cutoff lows here that could deliver some scattered storms into the what could be getting quite hot southwest. Now, this isn't fully monsoonal type moisture. That usually comes later in July and August and September, but it's moisture, and we need it into this area given how dry things have been there. Okay, from there, let's talk quickly about temperatures. Here's our frost potential over the next 7 days. I'm concerned a bit right around Spokane, and then here in the UP, even the northern part of lower Michigan and parts of Wisconsin. Temperature-wise, if that ridge does build into the west, you can take the color coding on this map and just flip it. And that's what early June will look like. Much more heat here and much, cooler. Not, be careful here. I don't want people to think it'll be cold, but it'll be back to normal, even cooler than normal in this section of the country. This is the May 1st to May 28th average temperature ranks by climate district. And this would be a significant flip quickly in the west, increasing evaporation rates and potentially pushing toward what I'd be concerned about would be a ridge getting stuck, which would automatically increase wildfire threat for so much of the western United States. So the temperature pattern looks something like this. Here's today's highs. Getting into tomorrow, this is tomorrow, Thursday, into Friday. So still a lot of cooler air here compared to what it could be for late May, early June. But watch the temperatures start to rebound in the west. This is Saturday, getting into Sunday. Sunday could be really hot into Monday along the kind of front range and high plains, western plains of the central United States. And then here's kind of our last trough coming through. There it is on Monday. By Tuesday, as that thing sneaks through, this is the one that produces that low midweek next week that rolls up into parts of Ontario. After that, this is going to be real common. Upper 90s, lower 100s in the Central Valley, heat south. And we're going to have to watch how this plays out because day 5 through 10, that's it. That's the last of this kind of colder air according to the current model forecast and where this pattern's going. And you see day 10 through 15. That's when the ridge is in place. The flow's coming through and over the top. This gives us that drier signal for here, wetter to the south, wetter to the east, but cooler compared to average, and the heat builds into the west. The CPC talked about it yesterday. This was their hazardous temperature outlook for excessive heat. They have a slight and a moderate risk for the Central Valley of California, the 6th through the 10th. So we're going to watch that carefully, but it's staying to the south and also down in Florida. And this is just indicative of where that large Mexico ridge that's flexed a lot east to west, but starts to move a bit farther to the north as time goes on in this pattern. Okay, how long does it last? Well, I was looking this morning at a few different model simulations, and I thought I'd show you the week 3, week 4. This would be June 12th through the 18th, and then the 19th through the 25th, according to the CFSV2. And if you notice, they've got this drier area here and here as we work our way through June. And I think the thinking here is that you end up getting flow that comes in like this and over the top. So we stay stormy to the south, stormy in the western Canadian prairie. That's where the flow enters. This is the base of the trough, and in between, northwest flow is drier. Okay, I mean, I get it. I see why the CFSV2 is likely doing that, but I don't often show you the CFSV2 because I find it to be just a bit more inconsistent of a model. There's nothing wrong with it. This is no disrespect to the people that make it, but I'll question whether or not we do stay as dry as maybe the colors show deep into June. It is a possibility, but at some point we will get into a stormier pattern through this particular area. The European model has been very consistent with its temperature pattern. Here's our next 7 days out into week 2, and then there's the heat that builds throughout the western United States. And so question becomes, does that ridge stay kind of on the continental divide? Does it move to the west, or does it start to move back to the front range? That will be the trickiest thing to figure out in the month of June. If it moves farther east, then we have a lot of people in the central United States that right now are absolutely soaked that will be very concerned about rainfall going forward. If it stays on the continental divide, all the heat will stay there as well. Storms will start to cascade over the top. If it even goes farther to the west, you get that scenario happening on a broader area. So 3 different areas, 1, 2, 3, to determine where by the end of June we see this ridge moving. And it'll be just critical to watch over the next 30 to 40 days as to its position. The European model on total precipitation, though, does look something like this for the month of June. I'll just take you to July 4th. So you can see that it's trying to put in some drier air under that warmth, under where that ridge is. But I just want to be clear here that drier, not dry. There will be storms in this area. There's plenty of local moisture to be recycled coming out of the ground and out of vegetation during that time frame. So we'll keep an eye on this pretty carefully. Okay, let's look at a couple other places around the world. I want to take you to the CPC gauge data on WeatherBell's site here, looking at the last 30 days. So a lot of Ukraine, getting into this part of Russia, even parts of northern Russia have been quite dry. And while Turkey, very southern parts of Russia, and then Central Europe have had quite a bit of wet weather. If we take a look at the satellite-based root zone soil moisture only for Asia, I want to point out a couple of things here. A lot of this was flooding way back in early May, late April. But we take a look at this part of Russia. We're still seeing some very dry conditions in through this particular area. We did see quite a bit of flooding south of the Yangtze River. We can still see that soil moisture is quite high in that area. But if we think about this, the concern is that this pattern that we got into, come back to this a minute ago, so highly amplified. This is what it's been doing across the North Atlantic into northern Europe and that part of Russia. Flow out of the north, there it is. That flow going into the Russian wheat belt is dry. And that's why we've had the dry conditions here. But it's been this trough that's kept much of Europe so stormy. I know it's going to turn your head. I'm turning my head to look at it right now. But the thing we're worried about is if this whole trough ridge pattern changes, it'll have a downstream effect as well. And some of the models are beginning to pick up on that. I mentioned yesterday that the European model 10-day was an outlier, trying to bring more wet weather into this area, just to focus on one spot here. But the other models have kind of picked up on this. The new artificial intelligence went a little bit wetter in that area. And this is going to be a little bit different projection here, but to come over here, even the GFS tried to push some wetter weather into Ukraine, although the GFS is still the holdout for the drier weather in this area. Real quick, before I leave this map, this is the tropical pulse of moisture that's going to combine with the trough here that may finally upset the ridge complex that's been in this area. So I just wanted to show you that here. And a couple last things to point out. Much above average, autumn weather here in terms of precip in Australia, and that region in southern Brazil continues to show up drier in the forecast as well, just to kind of keep tabs on what's going on there. All right, that's all I got for you today. Hope you have a good rest of your day, and we'll pick this up again on Thursday morning. Thanks.